Hello, everyone. Can you hear me? Yes. Thanks for coming. As you can see, today I will talk about writing portable CI/CD pipelines using Python. This is the agenda for today. Firstly, we will talk about some challenges you have to face when you write some CI/CD pipelines. Then we will talk about Dagger, a brief introduction first. And then we talk about how does it work more specifically, and some of its features, which is it can run almost everywhere. It has some multifunction, it has multi-language support, and it can run service containers and is excellent at caching. We will then have a brief demo if it will work, we hope, and then we will have some conclusions. When you write CI/CD pipelines, you have to face some challenges. The first one, you want your pipelines to run faster and fail faster. So you don't want to wait for all your steps in your pipeline to complete in order to see that the pipeline failed. You want also to run faster. You want to have good caching. Otherwise, you have to wait 40 minutes, 1 hour for a pipeline to run. Next, you usually want to integrate with the third-party services. For example, for running integration tests, you want to run a database, and you have some problems with the synchronization. For example, if you spin up a database, you have to wait it to be responsive. And you have to do some, for example, health checks or just add a delay in your tests to wait the database to be responsive. Then you have to manage also the life cycle of these applications for them not to use too many resources. Then you have the vendor lock-in. If you write some pipelines for GitHub using GitHub Actions, and you then want to move to GitLab, or to another CI platform, you can do it without entirely rewriting all the pipelines. And finally, you usually don't have local testing, and you end up doing some commits like this one with fix CI. You sometimes write the commit, you push, you wait the runner to be provisioned, then you wait again the test to run, and it's very time consuming, and it drives you crazy. Yes, I know it. It's not definitely a good user experience. And then it enters Dagger, which is a fairly new project. I think it has 1 year, 1.5 years, and tries to address some of the challenges of traditional CI/CD tools. What's Dagger? Mainly, it's a programmable CI/CD engine that runs your pipelines in containers using BuildKit. We will see throughout the slides and in the demo why it's important to use BuildKit and Docker. Then you write pipelines as code, not more as YAML files for configuration, but as code. This opens some interesting scenarios. For example, you can integrate with third-party system libraries or integrations, for example, for getting secrets, API tokens, or whatever from third-party systems. And you can also use your libraries you use every day writing your code. Then it's just code, so you can even test your pipeline like they are a normal program you write in Python or in any other language. And then there's the Lego blocks development, where, for example, you don't want every developer to know how to write CI/CD pipelines. Maybe you have a DevOps team that manages all the CI/CD pipelines, and these teams can provide the developers some blocks that they can glue together and just use them out of the box. This is interesting because you can, for example, write a library, a package, and distribute it. Normally, you when you write a CI/CD pipeline, you copy-paste from an old pipeline you have made all the steps. And if you, after copying the same step in 100 projects, you come up with a new idea on how to optimize this step, you have to update all the projects. And this is inefficient, and it's actually technical debt you have. Instead, with a library, it's just a library, so you may have some tools or some methods to automatically update libraries, and the DevOps team can update all the libraries without doing any change. As we said before, no, we didn't said. So it can run pipelines almost everywhere because it uses Docker under the hood. So any platform that can run OCI compliant, has an OCI compliant runtime, can run these pipelines. And almost every CI platform I'm aware of, can run Docker containers. It has cross-language support. It has an SDK for Python, for Go, Node, Rust, Qlang, I didn't wrote that, and the GraphQL. So you can use any language you want by interacting with the GraphQL APIs to write your CI/CD pipelines. And finally, it uses, as the name suggests, a DAG, or directed acyclic graph. So instead of thinking a pipeline as a line of pipes, you can think a pipeline as a graph, where the nodes are the steps and the arrows are the dependencies. So if you want to run a pipeline, you just have to tell Dagger which node you want to visit, and it will implicitly quoted because you designed the graph. It will know which steps it had to do in order to visit the graph and which path it has to cross. How does it work? It's fairly simple. You write your program, you write your pipeline using any SDK you want in any language, and you give that program you wrote, which is a wrapper around the. Oh no. Okay. Yes, which is a wrapper around the GraphQL APIs exposed by the Dagger engine. And then the Dagger engine interacts with the OCI compliant OCI container runtime and run the pipeline, as you can see. Every step, every node of the graph is executed in a different container. And it's interesting, and we will see why it's interesting in the caching part. This is how it runs everywhere. Yeah. You can write the pipeline like this. The Dagger engine is a layer over any Docker compatible runtime. Okay. This is the multi-language support. As I said, you can use any SDK you want. You can even use the GraphQL API playground to interact with it, and you can use any GraphQL client. You can write it in Bash, in C, or in any language you want. Then the GraphQL API is exposed by the Dagger engine. The first feature of that, The first feature of Dagger is service containers, which enables you to run network of services like databases or web apps as ephemeral containers. It manages all the life cycle of these ephemeral containers, and these services are started just in time, deduplicated, and stopped when no longer needed. It solves also the problems of waiting for the service to be responsible, performing some health check before letting the client interact with the service. And it also has some features to give an alias to the client for the service in order to use it. We'll see how in the demo. And finally, we have some out-of-the-box caching. Yeah, out-of-the-box caching. Because every node of the graph is executed in a Docker container, and Docker is exceptional at caching things. You can have some out-of-the-box caching, and if this out-of-the-box caching does not cover all your needs, you can even define custom cache volumes to use across pipeline runs, but also across different pipelines, because the Docker cache is shared across the pipelines, and you can also share the Docker cache between runners, because they are just layers, and you can push these layers to a registry and then share the registry between runners. We have now the demo. I hope it will work. Yes, you can see. Okay. The first, this is an example about writing a pipeline. We have a simple Python app. It's a fast API service, but it doesn't matter right now. We can configure the Dagger connection. We have a connection. We establish a connection with the Dagger engine, and then we use some methods to do a build of the container. This is the version 0.0, so it's the really first iteration you would have when working with Dagger. And right now you are doing a build from a Docker file. We have a Docker file in this directory, src service, which we load in the context here, and then we run the docker build command. And then it publishes the image to a registry. We won't run this because it's not interesting. There's an interesting feature of Dagger, which is eliminating the Docker file and writing Docker files inside Dagger. So the first version doesn't use any Docker file, and as before, we import some directories. We load directories, and then we write Docker file with methods on a container. We do the from, we set the work dir, we set a directory, so we copy a directory, the work dir we loaded before into a directory, and then we install the requirements, and then we set the entry point. Finally, we push the image and we print a message. We try to run this first build. This is the Dagger CLI. Printing a DAG is quite difficult, so there's this kind of graph you can see. Now it has some operation already cached, as you can see, because I already ran this pipeline. We also have, or no, we should have the requirements install, not cached. Well, it's already cached. I don't know. So it's quite fast, and it published the image to this repository. As you can see, it cached the installation of requirements, so it didn't even install the requirements. The second iteration is maybe we want to add some cache. It already has, but there are some ways, if you are not in this case, to have cache. For example, you can do a kind of multi-stage build. So you import, as before, the src, and you import the requirements. You load the requirements file separately. You create a container where you use as a runner, where you just install the dependencies, and then for building the image, you start from the runner you built before, and loading just, excluding the requirements, so loading just the code. And this way, if the code is changed, the runner will be the same, and just the image part will be executed. This is the out-of-the-box cache. If you want to use cache volumes, you can, and it's as simple as declaring a cache volume with a cache key, and then mounting this cache volume into the container. And this is reused. We won't run it. We run just the last one, which is a more complex example. In this example, we are loading a DynamoDB database, which the FastAPI program interacts with. So we can, as before, it's identical. We have the runner. We have a test runner, which is separate from the runner we seen before. And here we install the requirements dev, which is the different requirements we specified with just, here it is, with just PyTest. And then we define the DDB service. In this way, we are defining a service containers, which we were talking before, and we just treat it like a simple container. So we import it, we load it from an image, and we specify the exposed port. This is important because by specifying the exposed port, Dagger can know how to and where to perform health checks in order to wait it for be responsible, and then letting the test results, which is another step, to interact with it. How do we express the dependency between the test results step and the service container? It's just as simple as calling this method on the test runner and binding the service. We bind the service by indicating the container we want the service to run, and then an alias. This is the alias we use in the actual tests when connecting. It's a DNS, so when we, here we have the connection, and we connect to the DDB on port 8000. The DDB is the alias we set here. So we can have the test not dependent on the service, and we can put whatever we want, and just reference whatever we want in when binding the container. Then we wait for the result for the test to complete, and we get the exit code and the standard output for the command. We can have it, and then conditionally we can interrupt the pipeline. For example, if the tests fail, we can interrupt the pipeline and just return, printing obviously the standard output for the errors. And otherwise, if the tests worked fine, we can build the image and of course continue. We can run it. Maybe here we can see now. We should see that the service container, here it is, it's running, and it's also stopped right after the. Okay, it finished. Well, you would have some more time to deep dive into this this graph. There's also the last thing about Dagger. This way of running Dagger is the rapid iteration method. But if you want to fine tune, you can enable the experimental Dagger interactive TUI, which is a UI where you can see each step and see the output for each step, how much time it takes, if it's cached, and you can fine tune here. It's still in beta, it's experimental, but I think that in a few months it will be available. The demo is, okay, we are done with the demo. Okay. Some conclusions. Okay. A challenge you have to face if you use Dagger is that pipelines are not declarative anymore. Declarative languages are awesome in some way, and writing code, you can have some problems, and you have to be aware of that. Otherwise, you will write imperative code instead of configuration. And writing a graph or a pipeline is more a kind of configuration problem instead of yes, instead of a programming problem. You can have possible vendor lock-in. The aim of Dagger is to not vendor lock-in on CI platform, but if you use the feature of writing Docker files using Dagger, you actually are vendor locked in into Dagger. If you don't want to use Dagger to write your Docker files, you are losing a big part of using Dagger. So I don't know if I would recommend it. And finally, there's no multi-language package repository. You have multiple SDKs. You have the Go SDK, the Python SDK, and the community may develop some features or some additional libraries for Golang, for example, which is the most used right now. And if you use Python, you may lack some features. But yeah, it's the community. The core is exposed as GraphQL, so you don't have any problem on the core. And yes, that was it. You can find the slide on GitHub, not right now, but late in the afternoon you will. And you can also find me on LinkedIn. Thank you.
Okay, thank you, Philip. Even with all the glitching, you managed to do very, very well. Anyway, there are some questions for you here. This question is a little bit not clear to me. I'm going to try to make it clear for you. So the person who asked it, if I didn't rephrase it well, please come forward. What's the advantage of using Dagger to write the Docker file? Doesn't that lock you to a Dagger, making Docker file content less readable?
Okay, yes. The advantage of using Dagger is that you can use variables, you can reference objects, you can reference whatever you want. Instead, if in the Docker file, you have a lot of copy-paste, and I find it to be error-prone for typo. You do a lot. If you do a typo, it's easy to do a typo, also for me. And yes, writing code, you can reuse the code, you can write function, you can write more complex Docker files.
All right.
And the second was, well, okay.
Yeah, no, I can read it. Doesn't that make Docker file content less readable?
No, you have to forget about Docker files. You just write Dagger.
All right. Can you run an arbitrary bash command with the jobs of Dagger?
Yes, you can. You run your steps in container, so you can run whatever you want into the container. You can also write in bash the pipeline instead of Python if you want. Okay,
thanks. So what is the advantage of creating a Docker files in Python?
Yes, I think I answered to the first one.
Does Dagger integrates with the GitLab or GitHub with the web UI?
Yes and no. I was thinking about that. You can integrate. You can integrate with the UI by running small steps into the web UI. So you write for example, GitHub workflow, and you still have to define different steps. And in different steps, in these steps, you will visit a specific node. For example, you will have the step for the tests, and there you will visit the test node in the graph. And in the deploy step, you will visit the deploy node. In this way, you will have the visualization of your pipeline also in the GitHub or GitLab UI. Otherwise, you have just one step and run all the pipeline inside this single step. You will lose the visibility, but if you open the log, you will have, as you have seen, the graph of Dagger. But if you want to migrate from GitHub to GitLab, you just have to rewrite the Dagger command. It's way easier.
Okay. So maybe you answered this one, but I'm still going to read it, and then you can tell me. How would Dagger interact with, for example, GitLab pipelines?
Yes, I think that's...
Yeah. Okay. Will it be configurable in a way that we see all of the steps in the pipeline?
Well, you can, if I understood correctly, you can write a pipeline. If you have different steps, you want to, if I understood correctly, you want to visit all the nodes in the pipeline. You just can write a pipeline which call the function which are the single nodes. And by doing this, you can visit every node you want.
Okay.
Every step.
Okay, why do you think that imperativeness and a variables declaration good? And if you really like it, you could do that with bash as well.
What?
Yeah, it's a bit... Why do you think that... okay.
Variables declaration.
Did you understand?
I think that that declarativeness is better than imperativeness, if that's the question.
Yeah.
Because, as I said, writing a pipeline is not. It's a configuration problem. You have to configure the pipeline, and doing it declaratively is way easier when you have a big configuration to manage. When you have a small configuration, you don't care. You just write some code, and it's easy as that. But when you have to manage bigger pipelines, if you are not aware of these problems, of the problems of writing imperative code, you will have some troubles debugging your pipeline and yes, running it correctly.
Okay, thank you very much. We are out of time.
Thank you.
If you have